In this section, we are going to discuss the section 5.4 from chapter 5, redox reactions of metals and activity series. Acids reacting with metal, special case of more general phenomena. That's one of the single replacement reaction. Reaction where one element replaces another. And element will replaces another element or not. It depends on the energy level of the element that we are going to discuss on the activity series. Here metal A can be replaced metal B if metal A is more active, or non-metal A can replace non-metal C if non-metal A is more active than non-metal C. Let's see some activity series here. These are the metal with highest energy. Not only metal, element, and here the ions, and here the non-metals. If we look into here, potassium with high activity energy and top of this chart. That means potassium can replace any of the metal and ion below it. See some example. But if we look into copper, copper is significantly below of this activity series and the energy is less. So if we ask the copper as a free element, can it replace hydrogen, lead, tin, zinc, aluminum, calcium and potassium? No, because they are less energetic. In the same time, metal can replace any ion of a compound below it. If the ion on the top position and element is down, then no reaction. So that's the three things we need to remember. So the metals with higher energy are more reactive and can replace elements or metals below in the activity series. Obviously also ion. But if ion in the top and element in the down, then no reaction. Here we could see some reaction. See, magnesium can replace lead. This is, we can consider the single replacement reagent A and BC. So metal and metal salt, correct? So magnesium can replace lead and form the magnesium sulfide and lead solid. Yes, zinc can replace copper. But in the third reaction, if we look into silver plus copper, in that reaction, no reaction, because if we go back to the activity series, we will find the position of silver and copper. Silver position is down than the copper. So silver cannot replace copper. This is how activity series actually occur. Here we also can practice the redox reaction. For example, magnesium 0 and here magnesium plus 2 and here lead 0. That means this side is reduction and this side is oxidation. Now, non-metal higher in the activity series displacing non-metal below it. For example, we can see here non-metal chlorine and calcium bromide. So chlorine can replace bromine because chlorine in the higher in the activity series than bromine. Look back. Fluorine, chlorine, bromine, iodine. So chlorine can easily replace bromine. Fluorine plus potassium chloride. Fluorine can also replace chlorine because fluorine in the highest of the activity series. So this is how activity series actually works. We can see the more example and we can practice it. Now let's go back to our slide. See, zinc, left zinc plus copper sulfate, so zinc sulfate plus copper. So now we have to look into the position of zinc and copper in the activity series. So zinc is here and copper is down. So zinc can easily replace copper. So we can see here zinc ion take place of the copper ion in solution. Copper atom take place zinc atom in solid. Copper oxidizes zinc 0 to zinc 2 plus, and zinc reduces copper 2 plus to copper 0. More active zinc replaces less active copper. So this is how it works. Copper is less active, so copper cannot replace zinc. I hope you are already got it from since I first show you the activity series. The activity series I show you, it's actually very common pattern on the, even if you go to the Google site you will see. However, our book have another activity series. This is same thing, action is same, but the way they design and show the arrow little bit of just flip, see. So they show that the most active elements are down and increasing age of oxidation, and the opposite, I mean increasing age of reduction, the ions. So this is just, we have to consider if for example the potassium here is more active than this. So this is just upside down, and I personally like the other one, I'm very used to, so that's why I show you, but it is up to you. But if you look into, thing is same. So copper to gold, they are actually very less reactive or non-reactive. That's why gold is very commonly used, because gold normally doesn't react with many other things, we can easily oil it. And here we can see the from copper, I mean see the hydrogen, yeah, it looks hydrogen or lead, so react with non-oxidizing acids to produce hydrogen. So from here to here, so down, more active, and do not react with oxidizing agent, non-oxidizing agent, they are least active. So you guys can look into. So now if we little bit of see some example, and in the terms of oxidation reduction, we will see that why it react and why it's not react. So here if we see the ionic reaction, hydrogen ion here actually reduced to hydrogen gas. How? See here plus 1 and here is 0. So obviously the charge is getting down because plus 1 is top higher than 0. And here is strontium solid 0 to plus 2. So this one is oxidation. So see, strontium 0 reduces hydrogen ion to hydrogen gas, obviously. More active strontium replaces a less active hydrogen ion. So now let's go back to strontium and hydrogen ion position in activity series. See the strontium, and where is hydrogen? Hydrogen is here. So strontium can easily replace hydrogen. But hydrogen gas plus strontium ion, no reaction. Why? Because hydrogen gas is less active and than the strontium ion. So hydrogen gas cannot replace strontium ion or can't reduce strontium ion. We have some example or learning check we can look into. Using the following observation, rank these metals from most reactive to less reactive. So if here is no reaction, so it seems copper more less reactive, and zinc can replace chlorine. Magnesium can replace zinc. So here magnesium high active, and then zinc, then hydrogen, and then copper. So this is how you guys have to figure it out. Metals at the very bottom of table. They are very strong reducing agent because, see, look into here, 0, 2, here we have plus 1. This is oxidation, oxidized and reducing agent. They are very strong reducing agent, very easily oxidized. So sodium down to Cs, alkali and alkaline earth metal. React with water as well as hydrogen ion, and sodium react very violently. Free element or sodium metal. Sometimes we do this experiment, but very cautiously on the hood. See, reactivity varies by metal. Silver slight reaction, top of the activity series. As I am telling that some activity series just flip wise, so do not confuse. Whichever you feel easy, convenient, use it. Iron very little reactivity near top of the activity. Zinc somewhat reactivity middle of the activity series. Magnesium very reactive. So you guys can check and note it down. Can displace hydrogen from solution containing hydrogen ion. If metal is below hydrogen, then it can displace hydrogen from solution containing hydrogen ion. If metal is above hydrogen ion, does not react with non-oxidizing acid. You can see the check. But if we, I think we can go back and check into the. Here we go. Gold, mercury, silver do not react with non-oxidizing acid. They are the middle, they are the highly reactive. Predictive tools for determining outcome of single replacement reaction. Given a metal and the ion of a different metal, look at the chart and draw arrow from M to plus charge. Gold plus calcium. Reaction occur. If we look into activity series, we can see. But this is called ion situation. Calcium is top so that it can Let's see the situation actually. Where is gold and where is calcium? Strontium and gold cannot react with calcium ion and sodium ion. Yeah, because they are less reactive than calcium and sodium. And in case of gold ion and calcium solid, let's see the situation. Calcium, calcium, calcium. Where is calcium? Here we have the calcium ion. So here is the calcium and gold ion. See. So calcium is the top, so this reaction can be happen. So more active, more energetic. So calcium can replace gold ion. Yep. So in the beginning, you can take a activity series print and you can practice, and then you will very it seems easy, not tough. So you need to check it out the activity series and you need to answer. Now okay, I will make the another video for that. I don't want to do the lengthy this one.